Righto, g'day folks. Sorry, let's just adjust that a tiny bit. There you go. Okay, I have been asked by one of my Extension 1 students to go through Cambridge Extension 1 Chapter 4E, Question 6. He asked for a couple of parts of it, but I decided that I'd just run through the whole question to just, so we can all see what's going on there. So the question tells us that we've got two functions, L of x and Q of x. And that L of x is x minus 3. And that Q of x is x squared. Then it gives us a couple of exercises. It asks us to find L of Q of -1. Okay, so what does that mean? That means that in L of x, I substitute the Q of -1. So here's L of x. Everywhere I see an x, I substitute Q of -1. Well, what's Q of -1? Well, Q of x is x squared. So Q of -1 is -1 squared. So I might set that out like this. I might say that L of, because it doesn't equal that, I might set this out like this. I might say that L of Q of x is x squared. I take Q of x, which is x squared, and I replace the x there with that, is x squared minus 3. So now I can say that L of Q of -1 is -1 squared minus 3. Well, -1 squared is 1. 1 take away 3 is -2. Okay. Then it asks us to find Q of L of -1. Q of L of -1. Well, Q of x is x squared, but I've got to get Q of Lx. Lx is x minus 3. In other words, I'm substituting Lx in place of x when I consider Q of Lx. So Q of Lx is x minus 3 squared. I took Lx and I replaced x in here with that. Okay, so expanding this, I get, I probably won't even expand it. It'll be easier to work with this in this format. So Q of L of -1 is -1 minus 3 squared. Well, -1 minus 3 is -4. If I square that, I get 16. Then it asks me to find L of -1. L of -1. Well, that's kind of getting the same function and embedding itself in itself. So where I see L of x, where I see x rather, I embed L of x. So that's going to also L of x is going to equal x minus 3 minus 3. So I've taken x minus 3 and I've replaced x with x minus 3 in that. Okay, which just gives me x minus 6. So L of -1 is -1 minus 6 is -7. And then lastly, it asks me for Q of -1. So Q of -1, well, I need to find Q of x. So in other words, I replace x with x squared in x squared. So there's going to be x squared squared, which gives me x to the power of 4. So Q of -1 is negative 1 to the power of 4, which is just 1. Okay, very, very straightforward part A there, so it's not too bad. We've also answered part B in doing this because we've got expressions. So part B asks us to find that expression there, and this expression here, and this expression here, and this expression here. Okay, so we've answered both parts A and part B in doing that. Now, part C was the particular question I was asked about. So let's get into that and have a good look at what's going on there. Okay, I'm going to take note of these functions, L of Q of X, Q of L of X, L of L of X, and Q of Q of X, and I'm going to write them down over here just so that I've got a record of them for when I consider part C. So L of Q of X was X squared minus 3. Q of L of X was X minus 3 squared. L of L of X was X minus 6. And Q of X was X to the power of 4. Okay, so we'll just keep them on hand. We'll give ourselves some room to work. And now we'll look at part C. So part C says that we have to determine the domain and range of L of Q of X. L of Q of X. Well, L of Q of X is X squared minus 3. Okay, whenever we're asked to consider domain, we want to basically look for things that we're not allowed to do. So we're not allowed to divide by 0, we're not allowed to get the square root of a negative, we can't get the log of anything less than or equal to 0. There's a few more, but they're all the ones that you know, at this stage of our knowledge, they're the only ones we need to worry about. There's no divisions here, there's no square roots, there's no logs, there's nothing to worry about here. Our domain is all X. Okay? So our domain is all real X. Okay? So what's our range? Well, think about what the graph of this function would look like. This is a parabola that's been shifted down 3 units. So if we y equals x squared would normally sit with its vertex at the origin. Okay, we're being shifted down by 3 units, so we're going to be a parabola with our vertex down here at -3. Well, we can see from the graph very, very simply that our range is all real y, such that y is greater than or equal to -3. Okay, so I don't know if that negative came up very clearly. I'll erase that and do it a bit neater. Okay, so all real y such that y is greater than or equal to -3. Okay, that's question C, part I. So we'll label that. Part II, or part 2, asks us to find the domain and range of Q of L of X. So Q of L of X was this guy over here, X minus 3 squared. Okay, well, think about what's happening with the graph here. It's a parabola, but the negative makes it late. Remember we discussed the shift. If it was x plus 3, it'd be early. That would shift it to the left. If it's x minus 3, that makes it late. It shifts it to the right. So this guy here would look like, instead of a normal parabola with its vertex at the origin, our vertex is going to be down here at x equals 3. But what restrictions are there on our domain? There are none. There's no divisions, there's no square roots, there's no logs of negatives, there's nothing to worry about. So our domain is all real X. Our range, what we can see from the graph, is all real Y, such that Y is greater than or equal to 0. Okay. Okay, so I'm going to clear that off and we'll get into part D. Okay. So part D asks us what transformation maps the graph of y equals q of x onto y equals q of L of x. Well, let's have a look at those two graphs and see if we can't work out what transformation takes place. Y equals q of x is just a normal parabola, okay, that sits on the origin. Y equals q of L of x is x minus 3 squared. We've already just seen what that graph looks like. Well, what translation has happened? Well, it's been shifted to the right 3 units. Okay, so it's had the translation is it's been, sorry, the transformation is it's been translated to the right by 3 units. Okay, and part E asks a similar question. What maps the graph of y equals q of x, which we've still got here, to the graph of y equals L of q of x? So I'm going to stand back so you can have a look at that. That's the answer to part D. Part E is a similar question, except that they're asking not about q of L of x, but about L of q of x. Well, L of q of x is our friend over here. We've already seen his graph. Well, what transformation has taken place there? Well, the transformation is that it's been translated down 3 places. Okay. Hope that helps. Let me know if there's more clarity needed or if there's any more detail I can go into.